Our next speaker is Mr. Joe Hudspeth, Vice President of Business Development at All American Marine. The title is Hybrid Hype and the Realities of Building Green. Joe Hudspeth is Vice President of Business Development at All American Marine, Inc., a manufacturer of high-speed passenger ferries, research vessels, excursion vessels, and workboats in Bellingham, Washington. Hudspeth has been involved with maritime sales, marketing, and product development since 2000. He currently serves as a regional co-chairman for the Passenger Vessel Association, is a judge for the Worldwide Ferry Safety Association Student Design Competition, and frequently speaks and writes on boat buildings related issues. I'd note that one of their recent vessels, the Gulf Surveyor, is visiting Duke today and will be here at GSO in a week or two, which we're looking forward to.
Thank you, Dean Corliss. I appreciate the kind remarks, and thank you for the invitation to speak. Thank you, John and Unals, also for the invitation. Glad I made it out here to experience the blizzard. We were having 70-degree weather back in Washington State, so I should have brought some of it with me. I want to go ahead and just dive right in the interest of time. We do build aluminum vessels, and I want to mention to John that the intersleek paint is so effective it can actually move a boat without any propulsion. It's so slippery. We were launching a boat on the ways, and we weren't quite ready to go yet, but the boat was because of the slippery paint. So no harm was done, thank goodness. But it's good stuff, and we use it. I want to talk a little bit about the hybrid hype. Seems like hybrid is the buzzword right now in the marine industry. You flip open any trade publication and you see a new vessel of someone doing something that they're calling green or using hybrid technology. And by golly, we should. I mean, it's been since the late 1800s that the diesel engine was invented by Rudolf Diesel, and it's been the sustainable technology since then, but it's time for something new. And it also will allow us to decrease our dependence on foreign oil and fossil fuels. So we want to see a change in technology. However, I want to warn you that it is just that. It is a lot of hype still. It's not a solution that's available to everyone to use. We'll get into that further on in my presentation. Just really to get past the greenwashing, if you will, we're looking at mainly vessels that are 10 knots or less. These are vessels with low horsepower or low RPM applications, and they're not available to the mass market. They're very complex, very expensive, and they may provide you with some restrictions in how you can operate your vessel. And that's what I call the Cinderella principle. It's a very specific fit. It's not going to work for everyone. And lastly, I want to talk about the marketable difference. If the hybrid technology was so great, we would see everyone doing it. We would certainly see the diesel technology engine manufacturers diving more into this hybrid technology and producing something that's mass marketable. I don't want to naysay regulations or say anything bad against the EPA, but it seems to some extent that they may have stood in the way of innovation when it comes to green technology. The EPA had come out with a set of criteria, emissions criteria, that the diesel engine manufacturers had to meet on a rolling tier basis. It started with tier 1 and we're now at tier 4. And the engine manufacturers, their R&D efforts were constantly devoted just to meeting the next tier. And I think their nose was down and it was hard for them to see forward just because they needed to hit the deadline to keep their product moving out the door. It would have been much better, in my opinion, for the EPA to say, hey, let's look down to the future and say, by this date, engine manufacturers, we want you to be at this level of emissions. We don't care how you do it, just have at it. And their R&D teams could have taken a more proactive approach and really developed technology to be further along. We might have LNG that's more available throughout the low horsepower range as well. And so we are now at Tier 4, and it's the end of the regulations, and maybe now the R&D teams will be able to develop some more hybrid technology that's useful for the mass market. And I like to say I like to live in this gray area here. I don't want to be in ignorance or pie in the sky when it comes to hybrid technology and regulations. I think we need to be somewhere right in the middle, somewhere where we can live and breathe and that is affordable and available. So why do we want green technology on our boats? There's a variety of reasons. Typically, the bottom line, I just killed it, sorry. Typically, the bottom line is not one that we see people are embracing green technology. It is not a cost savings benefit right now. It's usually applying to appeasing various stakeholders. So when it comes to putting green technology on a boat, there are a variety of factors that need to be considered. What green technology is available, what infrastructure requirements are going to be required, be it fuel source or shore power requirements. What do the regulations say? How safe is it going to be? Am I still going to be able to accommodate my mission on board my research vessel? There's space and weight requirements that need to be evaluated. How much fuel am I going to burn? And what is the net savings am I going to experience with emissions? And all of this is a lot to balance. And it unfortunately ends up being the boat builder's responsibility to pull it all together. And it's a challenge. We'd like to blame the naval architects, but it's really the boat builders in the end who are left holding the bag to put it all together. And it's not easy to do. So when it comes to considering all these variables, the first thing we want to talk about is regulations and safety. Right now, there's not a lot of regulations out there when it comes to boat building in terms of incorporating green or hybrid technology. Typically, all of the research vessels that we build, they're going to universities or to NOAA or even Army Corps of Engineers, and we'll still follow U.S. Coast Guard standards. It's not a requirement for them to be inspected, but it's good boat building practices. And we'll use the Subchapter T standard for those regulations. And the thing without having a set guideline with these regulations is we as a boat builder or naval architect have to apply to the Coast Guard for consideration of installing this green technology on a case-by-case basis. Right now, the Coast Guard doesn't have any guidance as to how they're going to consider the installation of lithium-ion batteries. They're very concerned with potential fire hazards, weight issues, wiring runs, etc. Yet they put the onus on the naval architects and the boat builders to come up with a safe plan. And they will review it and approve it, but the onus is on us. Same with LNG and hydrogen. Right now there's various applications out there that the Coast Guard is looking at, but no standards have been set to date. Your hybrid technology must be complementary to the mission of the vessel. Unfortunately, you might solve one problem, replacing a diesel engine with an electric motor, but you'll create another one. Diesel engines have the ability to have power takeoffs, which you can drive winches and A-frames. If you don't have those power takeoffs, now you have to implement a whole nother new system just to run that equipment and keep your vessel going forward in its mission. Sometimes you have to sacrifice speed. There's not a lot of high-speed hybrid vessels out there right now, and if speed is key to get to your destination, you may have to forego that. Same with range. If you're fully electric, can't be too far from home until the electricity runs out and you need to plug back in. So things to consider. And then I also want to just remind people that as boat builders, we are subject to the laws of physics. These are our boats. They float. And they are in a confined footprint. So weight and balance is very important to us. We can't just load up these vessels with heavy batteries and expect them to perform the way that they should. So it sounds great. Everyone says, Joe, let's do hybrid on our boats. But there's a lot to be considered before these systems can be installed and be effective. I talked a little bit about the infrastructure requirements. We'll get into this a little bit more in my presentation in terms of the fuel, specifically LNG and hydrogen. Great potential for those fuels, but sourcing them and the infrastructure requirements are very high still. And same with shore power. If you want to be all electric, just bringing electricity to a dock may sound simple, but it presents a variety of challenges. Water and electricity are not friends. Lastly, when it comes to installing hybrid technology, you really want to set some specific goals as to what your target is that you want to meet. Be it reducing emissions, reducing fuel consumption, switching to a different fuel type. You can't do it all. You just can't do it all and say that you have a completely 100% green vessel. There's going to be some trade-offs along the way. Like I said, if you have to add additional systems on board, those additional systems are consuming energy, and so your net gain in terms of being green is probably offset. So I want to get into some of these available green technologies, talk about what is possible, what these eco-pioneers have done. Potentially these are still one-offs. We're seeing more and more of these applications being repeated, and I kind of use the rule of three. Once you see 3 of these installations, then this hybrid technology starts to trend, but most of these guys are still what I would call eco-pioneers. So we've seen Foss come out with their hybrid system. I believe this has already been talked about, so I won't go into it too much detail, but you're looking at a conventional diesel engine that's supplemented with an electric generator to help drive the propulsion system. A lot of battery requirements and integration. Integration is very complex. So you have a variety of manufacturers that are supplying things like the generator, the diesel engine, and the batteries. But then who's responsible for integrating it? You have all these different companies, and there ends up being a lot of finger pointing. And there's a lot of software and technology involved in pulling them all together. And so it ends up being a very expensive and very heavy system, and you can see it pretty much takes the size of a tugboat to put it all together. And it doesn't always work. The Port of Los Angeles was subject to what I call peer pressure. They were making their pier green, and they said, well, if we are making our pier green, we need to make our tour boat green. And so they decided to put in a hybrid system in their tour boat. However, they could not get all of those components to work together, and they got so frustrated, they said, heck with it, we're selling the boat. And so I think it's been sold recently, or it might still be available on eBay if you're looking for a new hybrid boat. LNG, great technology, low emissions potential. However, there's a variety of concerns when it comes to LNG. First of all, the tank size. You're going to have to be operating in an area where you can have frequent refueling capabilities available to you, or have very large tanks on board. Those tanks tend to be very heavy. We've also seen a lot of reluctance, especially now with the oil prices dropping. The focus on LNG has been slowed down, and so the engine manufacturers are not pushing that very much. And it's still a very high horsepower application. So for the masses, if you're talking about vessels that are 150 feet and smaller, LNG technology is really not a viable option today. There's no engines being made in that low horsepower range. And then policy is still being developed with the Coast Guard. They are looking at it right now, and they have formed a liquid gas carrier national center of expertise. And so they realize that this is a forthcoming technology, and they do want to be a part of it. Washington State Ferries has had a slow go at it. They've been working on getting their ferries repowered with LNG technology and issued a RFP, but they haven't moved on it yet. So we're still waiting to see what they're going to do and where those tanks are going to ultimately be located, which is up top. And that makes for a boat very unstable when you have weight up top. Also, the bunkering, HARVEY Gulf had to actually put in their own LNG bunkering facility to accommodate their requirements. Hydrogen fuel cell technology, great technology. In concept, hasn't been proven yet. Hornblower gave it a go. They worked with the Coast Guard for several years trying to implement it in New York, and ultimately it's on hold, is what I've been told. It was a challenge. They were actually trying to do a variety of things with wind and solar and hydrogen. And as it was talked about yesterday, hopefully Red and White Fleet with their cooperation or partnership with MARAD and Sandia will be able to bring hydrogen fuel cell technology to a passenger vessel application. So this was one we're watching very closely. Solar technology still needs to be developed further to be useful for general marine applications. Where do you put all those solar panels? You need a lot of them. How much energy are they going to be able to harness for you to use, and how fast will the vessel be able to go? A lot with the solar sailor application, they're trying to do wind, solar. It's a lot of components, and they can do maybe one thing efficiently, but it's very difficult to do all of these things efficiently. Here's one that I like. I've never seen this in operation, but it intrigues me. I guess if you live in a windy place, using some kite power might be an interesting form of hybrid technology. Here's one that's a little bit more scalable. And of course, yesterday, I believe it was talked about in detail, so I won't go over it here, but the Spirit of the Sound is great using the generator hybrid technology. And I think this could be a viable option. I'm still listing them in my Eco Pioneer category, but as they build more and more vessels with this technology, we'll move them over to the trending side. So what is realistic? Let's talk about some applications for green and hybrid technology, mainly just green technology that I think are viable right now today. Keep in mind that there are many shades of green. So this first one that I like is a fairly new technology, and this is using a hybrid transmission. And this transmission allows you to use smaller sized engines that are supplemented with electric motors. And so we can use the smaller sized engines that will burn less fuel and maintain our speed or range with these electric motor inputs. So this particular gearbox has provisions for 2 electric motors that can complement the diesel engine. So this is still diesel engine technology. The beauty of this is if you do have a battery source on board, you can actually take your main engines offline and then just drive the transmission directly with the 1 or 2 electronic inputs. So it's a good way to go. Here's another example of how that power take-in is mounted. And here's a complete system. This system is offered by Reintjes. They're a gearbox manufacturer out of Germany. That's another thing to point out is most of the hybrid technology we're seeing these days is all coming from overseas, Europe in particular. Very little of it is developed in America. So you can see that they have the power take-in on the gearbox. They actually have a supplemental booster on these engines as well. So this is a very complex system, but you can actually scale it down. And that's what makes it appealing is it's modular, and you can install it in a variety of boats. This is also another new technology that I really like. This is a motor generator which is actually coupled in line to the engine. And so it will actually act as an alternator when the engine is running and charge some batteries, and then it can decouple from the main engine and just drive the propulsion shaft on its own. CFD analysis, it's something that's available to everyone. Really work on streamlining your design, minimizing drag so that you can reduce your fuel consumption. I want to just touch briefly on hydrofoil-assisted technology. This is a technology that our company in particular specializes in. We've installed this technology on a variety of research vessels, survey boats. And you'll see here that once the boat gets up on the hydrofoil, the fuel consumption curve is very flat. Typically, we're seeing from 17 to 27 knots. And the foil system, I'm just giving you a quick overview. The main foil is mounted above the keel, at and slightly above the keel. I'll give you a quick little demonstration of how that works. This is the water line, and then the foil displaces about 1/3 of the weight of the boat, so it reduces drag. And so there's really no penalty for speed, and you're not burning any more fuel. I also want to touch on this one. This is what I call unconventional conventional propulsion. This is a quad propeller catamaran. We were one of the first companies to introduce this technology. It's a survey boat with 2 large engines and 2 smaller engines. They light up all 4 engines to run out to the survey site and then take those large engines offline and just do all of their survey work for extended period of time on the smaller engines. Lastly, I just want to hit on some of these green Band-Aids. The Tier IV system that's coming out is applying to engines 805 horsepower and above. I'll just wrap it up here. These systems are very large. They are reducing the NOx and the SOx, but they are very heavy and they're not going to fit in all boats. Here's an example of one of those systems. You can also use an after-treatment filter, which will heavily reduce the particulate matter, but it won't reduce any of the harmful emissions. And then here's my last slide. It was mentioned before, there is great benefit for having a fuel flow meter on board so you can really monitor your fuel consumption. And you can also augment your emissions by using a fuel treatment system like a platinum catalyst. You can reduce your emissions by 8 to 10% just with this catalyst system. So thank you so much for allowing me to speak.